Hey everybody, what's happening? We're here once again factoring polynomials as we've been doing for a little while right now. Some of you may not even have to watch this video, okay, because it's really just the same steps over. This time out, okay, it's a degree 4 polynomial. So basically, what happens is a degree 4 polynomial is really the same thing, but it's about twice the amount of work. Okay, you're basically doing all the things that you do for a degree 3 polynomial, you're doing them twice. Like you have a degree 4, you complete all the steps, get it down to a degree 3, then repeat all those steps again to get it to a degree 2 polynomial. And then at that point, you can use like trinomial factoring or decomposition, that sort of thing. This one is just a little bit different. So maybe that's a good reason to watch this video, as you will see. So I've kind of kept things moving right here. Okay, you can see that I did a lot of things already here. You may want to hit the pause button at some point. But again, the first few steps are the same. Okay, this is a degree 4 polynomial. It has 5 terms in it. There's no way we know how to factor this using any other shortcut method. Okay, there's no way possible for us to do that. So we just have to go through it. We have to go through all the trial and error and all that sort of thing. So I listed the possible roots. That's your first step always. And those are the factors of 24. And there are a lot of them. But once again, okay, I recommend starting with the 1 and the -1, which, as you can see below, okay, if I tried x equals 1, I got a remainder of -6. That's not what we're looking for. We want a remainder of 0, so it divides evenly. That's not the case here. And then when I plugged in a -1, I got a -36 remainder. I also do not want that. So again, these are things that you can try on your own, or if you're confident of the procedure, then you can just continue on with this video. You can see that the third root that I tried, an x equals +2, did give me a remainder of 0, which is what I'm looking for. So below, once again, okay, it's not necessary to write this with each question that you do, but I've been doing it just to remind you what is a root versus what is a factor. And you can see below when we plugged in +2, we got a remainder of 0. The number that you plug in for x is your x-intercept, also known as a root or a 0. And then the opposite of that, x minus 2, that is the factor. That's one of the 4 factors for this degree 4 polynomial. Okay, so what do we have from there? All right, well, let's check this out. Okay, now that we know we have our degree 4 polynomial, we found one of the factors. We want to figure out what's left in this big bracket right here, which is going to be a degree 3 polynomial. If you have degree 4 divided by degree 1, you should be left with a degree 3 polynomial. But what are the actual numbers involved with that? That's where synthetic division comes into play. So let's do some synthetic division. Putting the -2 up in the corner. Once again, just a reminder that the number in the corner is not the root number. It's not the number you plug in for x. It is the factor number, which is x minus 2. And then I can put my coefficients across. It's already in descending order, so no need to be concerned. There's no missing terms, so there's no 0 in there. And I'm expecting to get a 0 remainder. Now, what are the other numbers here? Once again, okay, we've been doing synthetic division for a while, so I'm going to go through this quickly. We're going to subtract, multiply, and so on. And then when we get to this, okay, this is what we're going to have. And I've made a mistake somewhere. Let me back up and see where my mistake was and see what is the issue here. And I see a mistake that I made. I copied things down wrong, all right? But I'm not re-editing this video, okay? This is just proof that mistakes happen, all right? And you have to go check your work. Notice here, okay, I have a -24. It's supposed to be not a +24. And now things work out correctly. So watch this. Now I can take a look, and I have x minus 2, and then the coefficients are from my synthetic division. So I have x to the 3 minus 3x squared minus 4x plus 12. Now, at this point, things are a little bit different. Okay, you could go through all those steps again and try to factor that degree 3 polynomial like we did in the previous videos and you already have completed. We could try that out. Okay, the only issue with that is that it's going to take a lot of time. You'll do your possible roots, which are the factors of 12, and you'll try each one at a time, and that will work. That will give you a solution in the end. However, you're always looking for shortcuts, and with degree 3 polynomials, which usually have 4 terms, in this particular case, this one can be factored using the grouping method. Now, how did I know that? Well, it's something that you could quickly try out to see if you want to save yourself some time. I recognized it because I look at the coefficients and I see 1, 3, then 4, then 12. I noticed that my second coefficient is triple the previous one. If you don't recognize these patterns, you could give it a go anyway. And then if you've forgotten and you just did the possible roots and you completed all those steps again, you should arrive at the same answer, even if it takes you a little longer. Okay, but recognizing these shortcuts is a great idea because watch what I'm doing right here. Okay, I'm just doing this off to the side. This is the grouping method of factoring. And what I'm going to do is group up the first two and the second two terms like that. Take out what's common. So I have an x squared. I have an x minus 3 remaining. Then I can factor out a negative 4 and I get the same thing. So I have the same thing in both brackets, which is what I'm looking for. So this is giving me an x minus 3 with the x squared minus 4 outside. And then I'll always be careful, okay, because some things can be factored even further. In this particular case, we have a difference of 2 squares, which can go even further. So I can say x minus 3, and then to factor the difference of squares, I have x minus 2 and x plus 2. So what I'm going to do now is I'm going to move back and I'm going to factor completely. I already have my x minus 2. Now that degree 3 polynomial, I just factored on the right side. So I have x minus 3, I have x minus 2, and I have x plus 2. And now we factored our degree 4 polynomial. We've got it factored into 4 separate factors. This is a good answer. This is an acceptable answer. However, we can make this a little bit more concise because you can see an x minus 2 and another x minus 2. So why not go one step further here and say x minus 2 squared and then x minus 3 and x plus 2. And there we go. We've arrived at the solution. And again, there's another way of doing that. You could have done the integral zero theorem and the factor theorem and all the trial and error. It would have taken up another page or so on this whiteboard. But you would get the answer like in 2 or 5 minutes later. Then I received my answer. So, I mean, it's always good to look out for these shortcuts.